Hi, how's it going? In our programs, managing memory is super important. Here's a simple example. Don't have to worry about what the rest of the code does. I'll just run this right now to show you what it is. It's basically just a Raycaster, simple Raycaster that you would find online or something. But what's super important is this memory graph, the performance over here. So I'm going to break it. What I'm going to do is, now every frame I'm going to call this do something function, and this do something function is going to cause a memory leak. Okay, so we have 1 byte times 1024 is a kilobyte times 1024 is a megabyte worth of space we're allocating. I'm going to limit this a little bit. Max steps is 1024, so we're going to leak at most 1 gigabyte. Now, if we look to the side here, we can see that the memory usage is just shooting up until about 1 gigabyte, and then it plateaus. So, okay, it doesn't affect performance too much. My machine has plenty of space, but let's have a look at that. So what we're doing, the problem here is malloc allocates some memory and returns a pointer to the memory which was allocated. At the end of this function, even at the end of this loop, megabyte is destroyed. But megabyte is a pointer to the memory. It's not the underlying memory. And so a malloc statement always has to go with a free statement. Now we can see the program is stable. Good. Okay, obviously this is not the only way to allocate memory. Another way to allocate memory is called stack allocation. So this is not, in a program we have a stack, which is kind of like the local space, which is fairly fast, and we have a heap, which has a lot of memory. So if we try to allocate a allocate a megabyte on the stack, then we have an error. And this is a stack overflow. So the error is basically that we can't really allocate that much memory. We can allocate a kilobyte, and that works. And that's freed at the end of the function, so there's no memory leak. But obviously, if we want to load an image or a sound or something, like if we're streaming some textures, that is not going to work for us because we don't have enough space. So the other solution is something called a standard vector or a standard array, something like that. Now, a benefit of these is something called RAII, resource acquisition is initialization.
Resource acquisition is initialization, which is the idea that you grab resources in the constructor and release them in the destructor. It's also the best example of why I shouldn't be in advertising.
The basic idea of RAII is that if we use standard library data structures for our memory, then behind the scenes, this is heap allocated, so we don't run into the stack overflow, but it's also scoped to the function or the class. So here we can see that this vector is really declared inside this loop, and at the end of this loop, that memory will be freed automatically. So now we're doing, well, of course, the function doesn't actually do anything, but we're letting it run, and the memory is not growing. I said it's not growing, but now it's fine. It's not shooting up to 1 gigabyte. That's perfectly fine. So while I got you here, let me tell you a horror story. One project I was working on, a little hobby thing that I was doing, I had a menu and I had the game, and I kept jumping between the menu and the game to test it. And every time I jumped, this little memory graph went up by about 4 or 5 megabytes. And that's really scary because the project I was working on, it wasn't massive. It was about 6,000 lines of code. Try find a memory leak in 6,000 lines of code. Luckily, I found it without too much issue. It was an audio file that was being loaded but not freed, not released. But yeah, that's an example of where it's bad. Obviously, in game development, memory leak is not the worst thing, right? The worst thing that can happen is the game crashes and someone complains on Twitch or something. But that's fine. The issue that comes into play with memory management is if our program is running for a long time. Okay, so we could have a tiny little memory leak, which is hard to detect because it's small. Because the program is running for a long time, like a server or something, then that will build up and cause massive unpredictable problems. Or of course, if we're just making any sort of software which isn't a game, which is we actually rely on it to do something. Anyway, so this is just a little example of memory leaks, what they are, how we can cause them, how we can fix them. And yeah, anyway, hope you had fun, and I'll see you in the next one. Bye.